I'm James, and today I will be presenting the paper FAME, Supporting Continuous Requirements Elicitation by Combining User Feedback and Monitoring, which was written by Mark Oriel et al. And is in the proceedings of the 2018 26th IEEE International Requirements Engineering Conference. As the title suggests, this paper deals with combining user feedback data with monitoring data in order to facilitate continuous requirements elicitation. But before we look at the details of the paper, let's talk for a minute about how software requirements are elicited. If you were to make a list of all the ways that new software requirements are elicited after a piece of software has been deployed, you would have a large list, and you would probably find that the list of techniques could be divided up into two groups. The first group of elicitation techniques would be used for software that has localized stakeholders, and it would just include techniques that we have already studied this year, like interviews, focus groups, and brainstorming sessions, to name just a few. These techniques are relatively straightforward, given that they usually involve direct contact with the stakeholders. However, getting stakeholder feedback for some software deployments can be very difficult, especially when the software is widely distributed, like an app for a mobile device or a website for a bank. In this case, gaining insight into user needs and wishes in order to elicit new requirements is done using remote methods, and all of us have witnessed this process firsthand, and whether we realize it or not, we've all been active participants in helping software companies refine their software. So how do companies with globally deployed software determine how to refine their requirements? Well, there's two primary ways, and both of them involve collecting information from the end users. The first form of data that companies use is called user feedback data. And this data becomes available to the developers when users leave feedback on something like an app store. For example, companies can use the average rating out of 5 stars in order to determine how their software is liked by its user base. And developers can use user comments to learn about bugs that people have discovered. They can also see what features people particularly like or what features users would like to see added to the next release. So that's user feedback data. The second form of data that companies use to refine their software is called usage monitoring data. And this is information that is recorded by the software we are using. And it includes the links we click on, the time of day that we use the software, the amount of time we spend on each different software page, as well as any processes that we're running if the software crashes. And this form of data, usage monitoring data that is, does not need the user to create a review because it's almost always collected automatically and continuously. In fact, if you're using Windows 10 right now to watch this video, then by default, Microsoft is collecting all of your activity on your PC. And if that seems a little bit intrusive, this monitoring was actually something that you agreed to when you accepted the terms and conditions of the software the first time you used it. So, in their paper, the authors present a software tool called FAME, and FAME stands for Feedback Acquisition and Monitoring Enabler. And the tool basically continuously combines real-time user feedback with real-time monitoring data to support continuous requirements elicitation. And the motivation for this tool is that currently there's plenty of companies that use user feedback and monitoring data to elicit new requirements, but no tool exists yet that combines and analyzes both forms of data to support the particular goal of continuous requirements elicitation. So that's the motivation behind the software. So, why is combined feedback and monitoring data helpful? Well, first of all, user feedback can be incomplete. So, for example, maybe a user leaves the feedback, "This software always crashes." Well, maybe in fact the software is fine, but the user has a virus causing the software to crash. Or maybe the user leaves the positive feedback, "I love this software." Well, if that's all they say, a developer would be left wondering which features that person was using that made them love the software. And maybe someone doesn't leave a comment at all, but leaves a rating of 1 star out of 5. If this is the only information that a requirements engineer has, it's not very helpful for eliciting new requirements to improve the software. And they're left asking, why did they leave only 1 star? So, in the absence of monitoring data, the developers will not know the answers to questions like these. And then, in the same way, monitoring data by itself is insufficient in that it does not provide a fully complete picture of what needs to be changed or added to the software. So, without user feedback data, there may be new features, for example, that users would like to see, but they have no way to communicate this to the requirements engineers. Or users may have complaints about a portion of the software, such as how unintuitive it is or how many steps are required to get to a menu item. And with monitoring data alone, this information can't be known. But when you combine user feedback with monitoring data, now you have all you need to answer questions like these. So, how does FAME work? Well, first, if we look at the user feedback section, the user will provide his feedback through FAME's feedback component. And so, how does this component work? So, this is a possible implementation of the feedback component. And this particular interface allows the user to click on the green feedback button seen at the top right of the screen there at any point during their usage of, in this case, a website. And they can then leave a comment or a star rating or attach a screenshot with annotations. They can record a voice memo right from within the website, and they can also check a category for their feedback. And if they want, they can even upload additional files. So in addition to collecting user feedback, FAME also collects monitoring data by collecting runtime events from the host application using the monitoring component, which you see highlighted here. And since the monitoring data is continuously streamed from the user to FAME, it's stored in a data lake, which, if you've not heard of a data lake, techtarget.com defines a data lake as a storage repository that holds a vast amount of raw data in its native format until it is needed. And then once both forms of data, so user feedback data and monitoring data, once both forms of data are collected, the data is then combined, and it works like this. When a user submits feedback, that feedback is immediately sent to a combiner, which pulls that same user's monitoring data from the data lake. This monitoring data includes all of that user's activity from the time she logged into the system to the time the feedback was submitted. And it's this combination that allows a requirements engineer to see exactly what the user had been doing in the software prior to leaving a comment. And it's basically this fusion of information that makes FAME so effective in helping engineers solicit new requirements. So if a review is left that says this program doesn't work and the user leaves 1 star, the requirements engineer will be able to see exactly what the user expected to work that did not work. So how does the combiner work? How is the feedback data tied to the appropriate monitoring data from the data lake? And the answer here is by using what is called an ontology. And Stanford researchers Natalia Noy and Deborah McGinnis define an ontology like this. They say An ontology is a formal, explicit description of concepts in a domain of discourse. And these concepts are also called classes. That's the first part of an ontology. It also includes the properties of each concept, describing various features and attributes of the concepts. And so these features are also known as slots. And finally, the restrictions on these slots are also part of an ontology. And these restrictions can also be called properties, the restrictions on the properties can also be called facets. So, for example, take the domain of wine. There could be several concepts or classes in the domain of wine. For example, a class of wine could be Bordeaux wines. In other words, all wines made in the Bordeaux region. Classes can also have subclasses that are more specific than a higher level class. For example, white wines or red wines are a concept in the wine domain. And then properties or slots of a class in this case would include winemaker or the body of the wine, and a value of winemaker property. The winemaker property could be Chateau Lafite Rothschild, and a value for the wine body property could be full, like a full-bodied wine. And then finally, facets or restrictions on the property wine body would be that the wine body property can only be one of three options: light, medium, or full-bodied. All right, the image on the right is an excerpt of the ontology that FAME uses to combine data. And in this case, the classes in the domain are feedback and click monitoring event. The class feedback has the properties rating, image content, category, and then if you look in the middle, user, timestamp, and application. And then the class click monitoring event has the properties, the property element value and URL, to name a few. And it also has three of the same properties as the feedback class, which are user, timestamp, and application, the gray boxes in the middle there. And so using these three shared properties, FAME combines user feedback with monitoring data and presents them as a unified whole to a requirements engineer who will use this unified information to elicit new requirements. And there's also one other way that feedback and user monitoring can be combined in FAME, which is highly flexible and does not have to be tied to user, timestamp, or application. And in the diagram to the right, this concept is called domain concept. An example would be invoicing. If a user leaves feedback about invoicing, the monitoring data can also be queried for events related to invoicing as a way to join the data together. Okay, not only can FAME combine data, it can also analyze the data to help filter it to what would be most useful for eliciting new requirements. So for example, it can present only the feedback that includes requests for new features or the feedback that's negative. And it's able to classify the feedback in this way using machine learning, which is defined as a method of data analysis that automates analytical model building. And it's a branch of artificial intelligence based on the idea that systems can learn from data, identify patterns, and make decisions with minimal human intervention. To validate the usefulness of FAME, its designers partnered with Centercom and implemented the FAME system in Centercom's website, which has over 5,000 users. And then 2 workshop phases were conducted within Centercom with a Centercom requirements engineer using the data collected by FAME. The first phase presented the requirements engineer only with the user feedback data, which he used to elicit 19 new requirements. In the second phase of the workshop, that requirements engineer was presented with the combined data, and using this data, he found an additional requirement and modified 4 other requirements generated earlier in the workshop. So in conclusion, having user feedback that is combined with monitoring data provides a requirements engineer with a more complete picture of user needs from which to elicit new requirements than only one or the other. And utilizing an ontology is a viable method for combining feedback and monitoring data. And finally, the architecture utilized by FAME is proven to aid a requirements engineer in the process of continually eliciting new requirements for widely deployed software. And that is all. Thank you very much.